I'm starting an Arduino project where the goal is to make an electronic setting circle. Astronomers are familiar with setting circles and know what they are. They're the dials found on some telescope mounts that show where the telescope is pointed. Setting circles are used in pairs. We're used to a skyward direction being given as a heading and an elevation. Astronomers use right ascension and declination to locate celestial objects. The astronomers who take photographs of the night sky usually have the equipment to precisely determine where their scope is pointing and what they're looking at. They don't need the gadget that I'm planning. On the other hand, if this project succeeds, casual visual observers using a common photography tripod or just their hands to hold a pair of binoculars could use the electronic setting circles to help them find a deep sky object when they know the right ascension and declination from a catalog. And besides, who doesn't like gadgets? Even if you have no interest in astronomy, I hope there'll be some practical AVR techniques that'll be of some value to you. The project will use interrupt-driven devices. That's the plan. So far, the TWI is interrupt-driven. The OLED display is in working order, and it has a symbiotic relationship with the TWI interrupt. The project will have a way of selecting and displaying the information. The OLED appears in many Arduino tutorial videos, but the encoder, on the other hand, is rather unique because it's a TWI device. I found it on Tindy. I'll leave a link to it in the description. It appears that it will accumulate a pulse count, which can then be retrieved over TWI. It may save some coding and program memory. We'll see. The electronic setting circle project will need a GPS module, which will supply the latitude and longitude position, and as a bonus, the time, so I won't need a real-time clock module. An MPU6050 will be used to capture the elevation and heading of wherever the device is pointed. Drone builders will be familiar with the 6050. If things go well, I might include an SD card reader to hold a simple catalog of deep sky objects. The catalog won't be very big. It'll store only the name or ID of the object and its celestial coordinates, and I'll only add celestial objects as I become interested in them. I use the Microchip Studio to write and debug the code. The target microcontroller is the ATmega 328P, for which I will be developing on the ATmega 328P Explained Mini, also by Microchip. It has an onboard debugger and integrates perfectly with the Microchip Studio. When I'm done, the ESC project will reside on either the Uno or a Nano because I'm overrun with these. I'll have to keep a close eye on the memory requirements. If it gets crowded, I might switch to the Nano Every. This project will depend heavily on two-wire communications, so it will be important to see what's happening on the bus. I use a logic analyzer to eavesdrop on the data, and pulse view to display it. The code I've written so far for TWI and the OLED display has evolved into a couple of libraries. I'll explain them in a future video to let you see what's going on inside. I made this video to introduce the project, and for me, a kind of running start to document the project. In closing, I'll just say thanks for watching.